So welcome. That's the first presentation at code.talks from Akamai. So a premiere. And we're talking about web performance, which is a topic I have in mind and would like to see more here. So I'm a solutions engineer at Akamai. I had a software development background. I was 8 years at Adobe, and then I switched to Akamai as a solutions engineer. And I'm working with actually all the major e-commerce customers that we have in North and South. And probably lots of them are using us, and you don't even know. So who ever heard about Akamai? Okay, perfect. So today, actually, I took out the topic images, because especially at e-commerce, images are really important. And what we see is that most people don't use or deliver images the way they should and are not at the state of the art. So I'll give you a little overview about 5 challenges I see in image delivery today in the web. We'll start why we need images. Probably everyone knows it. What is the actual image problem today in the web? The challenges are, I took out 5, which I think are the most important ones. So why do we need images? Actually, a picture says more than 1,000 words nowadays. So if you look at the websites, and especially e-commerce the last 10 years, you would see less and less text and more images. Actually, and bigger images with more content. And actually it shows that 63% of mobile and tablet shoppers actually first look at the image before they read the text. If the image is shitty, basically they don't buy anything. Furthermore, articles with images, news, products, whatever, 94 have more total views. Even if you just have one image in a news article, it's more likely people will read it. Even if the text might be really interesting, but like the first step of continuing actually is through the visuality. So that's really important. And yeah, it makes money too. So at the end, if you look at probably statistics that e-commerce is looking at, if you just produce 1 second delay in your page load time, it could increase 5 to 7% in your conversion rate, because people are frustrated because the page is slow, the images don't load, they don't see anything. So that at the end could also again produce lower views and decrease the subscriptions and so on. You could lose a lot of money. So it's important. Every time you talk about website performance, images take over 80% sometimes of the site. So everything we do there, even if it's just a little bit, has a huge impact, much more than thinking about minification of JavaScript or anything else. If the images are not loading fast enough, then you're in trouble. And why is that important today more than 10 years ago? If you look at the average page weight, today it's over 50% images. So of all the content on websites, and that's from the Alexa top 1,000 websites, images are by far more than 50% of the content. So it's worth looking at them, basically. Second thing, if you compare 2010 with 2015, first of all, you see we now already passed the 2 megabytes 2015 on average load time, just because of images, mainly. And the images actually are 2x more page weight than the whole site on average 2010. So only the images are factor 2.3 from the all content that we had 10 years ago, 18 years ago. So what is the image problem? So basically, all of us basically want to deliver really nice content. They want to take the high quality images, put them, raise the conversions and lower the bounce rates. The problem is those images, it's hard to deliver it consistently over users, to have across all inconsistent mobile devices and inconsistent connections. That's pretty challenging. At the end, you will end up creating more sizes to have a responsive design. You want to have all the new formats that are out there. You have new layouts depending on the cropping and so on. So you end up with lots and lots and lots of variants of images. So, and then, besides storing and all that, you have to basically somehow put it in the code. When is the situation basically, when do I have image A, when should image B be loaded, and so on. So it's pretty complex theme if you want to do it right. So that's, if you just do a little math, if you think about a little page and you want to support 3 sizes, which is not a lot, but let's say 3, so mobile, tablet, and desktop. And you would want to deliver it in all those new formats: WebP, JPEG 2000, JPEG XR, PNG, GIF, and so on. Let's say just 4 formats. You'll end up with 3 times 4. And then you have all the pixel densities, 1x, 2x, 3x. So you have to multiply them, you have another renditions, multiply by 3. And then the designers come and they think, I want a layout, I want a cropping, I want a background different, I want whatever. So let's say just 3 layouts. Alone there, you end up with 108 variants of images. They need to be created, they need to be stored, they need to be managed. They need to be managed in the cache effectively and switch them if you have to purge them. So it's getting complex here. So just picking out the 5 most important challenges, and we'll dive into every one of those. One is resizing. Pretty obvious. You want to do responsive web design, you need more than just a 4K image. Otherwise, you'll get in trouble. So what variants do you need? Where are the breakpoints that you need to use? So what is, we'll talk about that topic. Oops. Then web formats. Actually, probably most of you will just use JPEG, maybe PNG. How much of you ever heard about WebP, JPEG 2000, JPEG XR, Hive, all those new formats? So we talk about that and think about when should we use what format and how actually can we handle this complexity. Then compression. Who of you is using JPEG 85 as a standard? Probably a lot of you. Is that the right way to do it? Does that work for all the other formats? So how can we actually maybe create something more dynamic here? And at the end, how do you implement that in the code effectively? So I'll go into a little bit into deep code there. And what of all of that can be automated? Because I'm pretty sure you don't want to build all this complexity yourself at some point. Some you can, some you can't, because it's just too complex at some point. If you really want to automate things, things get a little bit better. So talking about resizing, why should you resize images? Pretty obvious. If you don't resize image, you will deliver bytes that will never be displayed. We call that overloading. So you deliver 20% of the image, but it's never displayed on the screen. So it's waste of traffic, waste of network, and at the end, if you think about the uncompressed image on the low memory device, you have constraints of the image itself to actually load that image, although it was never displayed. So that's all things you have to have in mind. So just a simple example, if you have like this watch, a PNG 500 times 300 to 1200, but you wouldn't deliver it to a screen size that's only 350 times 420. So if you resize it, only resizing, we don't talk about compression or anything, you will end up with just 85% less bytes. So 85% less bytes means a lot of bytes, a lot of improvements. So if you really deliver the right size for the right device, you'll save a lot and you'll have lots of performance improvements. So one more thing which is important, where actually is your image at the end painted? So if you think about the devices, they'll get the image, they'll load it down, they will decode it with an encoder, JPEG, whatever, and then they will copy all this information, the pixel information, into the GPU and from memory first, and then into the GPU, and then display it on the screen. So why is that important? Little math example. So if you have an image which is 1280 times 420, every pixel actually that is displayed, not stored, displayed, is 4 bytes, right? So RGB and maybe alpha. So if you multiply that without compression, anything, basically just the raw data that's being displayed on the screen, that's around 2.5 meg. I mean, it's pretty there are some compression algorithms, but in general, it's a huge amount compared to the compressed image, which needs to be loaded in memory for this device. And what is the problem, actually? Vice President of Product says, I don't know what year that was, but it was pretty recently, 25% of the new Android devices only have 512 MB of RAM. So maybe you don't have that in mind while developing, while having all those huge images shifted into memory, and then wonder why is this, this Android, if you look at your user monitoring, for example, why is Android so bad? That's because you have lots and lots of really, really crappy phones out there. And but that's also users that are also customers that will buy something from you. So just a comparison, same network, same image, but different devices. You can see the decoding time differs dramatically because they have troubles shifting all this data from the memory into the GPU. And even if the network is same, even if the network is really good, even if the image is small, see, there are lots of differences there. So every bytes that you transfer that are not being displayed are waste and will have this problem more. So try to reduce the sizes that you actually deliver. So if you resize in browser, which you probably will do at some point, you can't do every single size. At some point, maybe you have to resize. But how much would you waste? How much does it mean if you, for example, reduce every image by 50 pixels? If you reduce it by 50 pixels, let's see, one image is big and one small, you'll end up with wasted bytes. But for the same amount of wasted space, the bigger image is more wasted bytes than the smaller, naturally. So that means if you look at breakpoints, you should think about more breakpoints towards the larger images and the larger screens than at the smaller, because every wasted image here, every scaling down on the big images is more wasted bytes. So if you think about strategy, where to put your queries and where to put your breakpoints, think about how many wasting bytes you have. Ideally, you should hit it by a byte and don't have any wasted image, but sometimes that happens. Think about the pixel density. With the iPhone came the Retina display. That means actually you have the same screen here, one without and one with Retina. CSS, same thing. You will render it the same size. The image, physically, it's one-to-one relationship because we have every pixel is every pixel is displayed as an inch. You have 1 inch per pixel, basically. Retina just doubled that. You have in the same space, you have more bytes. It means you're still rendering 320 if you think about image sizes, but if you don't physically provide the double amount of bytes, you will lose that nice visuality from the Retina display to having really all those pixels displayed and have that nice effect, especially on curves and all of that. So, but size isn't everything in life. So besides size, actually, art direction might be an important thing. So think about an image of a dolphin. If you don't care about art direction, you would say, okay, I'll just care about size, so I'll deliver size in the right space and I'll just push it out. Art direction would say, you know, on a mobile phone, if with that view distance, I want to zoom into this dolphin, so otherwise the whole experience is crappy. So if you think about those kind of variants, that means you don't have you not only have different sizes on different devices, you also have different art direction at the end. Web formats. So web formats today, I mean, that's already 2 years old, but it's pretty stable now. Most of them are JPEGs, lots of GIFs, but those are mostly ads and things like that. So in e-commerce, I would say mostly JPEGs, mostly PNGs, some SVGs, not a lot of WebPs, and some others. So imagine there are new flavors of JPEG, and of course there is no standard. Every big vendor did its own thing. So, for example, JPEG everybody knows and supports it natively. But there are new formats. WebP. WebP is developed by Google. It supports transparency. It supports it's a progressive and lossy format, same as JPEG, but it's with the same quality, 30–35% smaller in bytes, just out of the box. It's supported by Android and Opera. Then you have JPEG XR, supported by Windows, same story. JPEG 2000 is actually the format that iOS and Safari is natively supporting. Same story. No others support the other format, so we have to make sure that really just the formats are delivered to the right devices. Apple just announced a new one called Hive, which is currently not supported in browsers. It's basically more a video format because it has all these live video parts in it and stuff like that. But at some point, I guess it will become a browser because they want to push that format. So probably this list is not ending. There will be more coming on. So what is the right image format at the end for you? There's no good answer. Actually, it depends. So if you look at an example, you have an image and you zoom in, and then you have some transparency that you have to have. You'll choose a PNG, I guess, today. Let's say a size of 185. The JPEG would be much smaller, so it would be much better choice. But actually, guess what? JPEG doesn't support transparency, as we know. But WebP does. And WebP does and is better in compression. So if you look at there's a lossy and a lossless format. So basically, if you just even don't go into the lossy format, the lossless format, it's a bit small here, is already kind of a little bit higher than the JPEG, which is lossy. But if you look to the lossy format, basically it's already much, much smaller. It's 22K, and you have alpha in there. And it's the same visual quality. We'll get into quality later. But so basically, depends what browser do you actually request that image? Is it alpha or not? And there's one more thing you have to keep in mind, and that's a little, I'll go through it pretty fast. It's the fact that the human eye actually is pretty good at distinguishing changes in light. It's much, much better in light than with colors. That means we can trick the eye a little bit and maybe get some more compression. That's called chroma subsampling. Anyone heard about it? So basically, I'll just show you in a couple of slides what it is. Chroma subsampling, actually, there are different numbers. So after this talk, you know what those numbers mean. 444 means it's always it's a patch of 2 rows with 4 pixels, and you go through it, and you create chroma and luma. Chroma is the image information out of the pixels, and the other one is the light information. We will never change the light information. We will always think about less colors. So in this case, we do 1-to-1. We choose from every pixel the color information, and from every pixel the luma information. That's it. That's 444. The result is something like that. 4-to-2 means we skip every second color information in the row, so we end up with 2 rows, but with still 2 rows, but only 2 columns. So that means we'll have just 4 color information, but you still have all 4 luma information. That's important because our AI is pretty good at that. End up something like that, and 4-2 is basically the same, but skipping every second column information. So it's basically just 2 color information for 8 patch pixel. And we end up something like that. In my example, it's pretty obvious that there are changes, but if you look at real images, you won't really notice differences, especially on pictures. So why is that important? If you think about an example image, you see that you can get up to 62% of memory saving. Now we're back to the image, so we don't have to load all this information. We're not at 4 bytes per pixel anymore. We're much less. That means you'll save memory. Of course, you'll save, it's also used by all those new formats, because that's where you basically do a good compression, a lossy compression. Which format supports subsampling? JPEG, yes. So probably you do that already. If you do Photoshop and say save as, you can choose what subsampling you want to have. So maybe you check what you're using today. WebP in the lossy format only supports 420. So basically the best you can get. JPEG 2000 XR support that. PNG GIF are not lossy. They don't do that. So when should you use what? Basically, for all images, you can use 420 without any problem. If you have logos or sharp text somewhere, you might get into troubles because those sharpness will lose. You can try to do that with CSS or render that into the without rendering into the image. Use PNG, but it really again depends. Sometimes it's pretty good, and then you might have to lower your compression or maybe do some smoothing on top. So it's not a recommendation. It's just if you have logos and high contrast text, then be careful with 420. Compression. So lossy versus lossless, actually pretty easy. If you have a lossy format and you compress it and decompress it, you'll never get 1-to-1 the same as before because you lose information. But obviously we try to lose this information that's not important for us or that the human eye is not perceiving at some point. So if you look at those rows, wonder how this big screen, yeah. So you will see that in the top, you will see more differences, hopefully, than on the bottom. So what is the best image? That's a good question. What is image quality? How do you define image quality? Probably if you ask your designer, you say, I can't explain it, but I'll show you. This is the best, JPEG 100, although there's no proof for that. So actually, if you look, there's 2 things where quality is being defined. One is there's a relationship between compression rate and size. If the compression rate is more aggressive, the file size goes down. And there is a relationship between quality human perceptual quality and compression. And it's not linear, otherwise you wouldn't see so much differences on the top, which is just between 5, 10, and 50 quality level, and you see much, much less on the upper. That means actually we end up by JPEG with something like that. So the quality decreases a lot. The quality, so basically you have the quality levels on the X, and on the Y you have the file size. So actually after 60 there's just limited returns in terms of file size. Nothing really happens there anymore in terms of quality, in terms of file size, but in quality, yes. So basically the large reduction, in JPEG at least, between 100 and 90. So then there's this user experience. So we have file size at one point. You could just look at file size. If you do that, you'll get into trouble because best file size is down there, but it's really poor experience. It's a good performance because the images are really small, but that's not what you want actually. If you just go to quality, then probably the designer says go there. Quality is good, but the performance will be bad, and people will be annoyed. Happy users are somewhere there, because the quality is nice and the size. So there's a balance you have to find. And if you just put it straight to, so is that true for all images? No, this curve is different for every single image and every single size. If you have an image with a high frequency, it might be much, much sharper. If you have something that is pretty easy product page, it might be different. So you can't just say JPEG 80 will fit everyone. That's why someone or a couple of people that are pretty smart invented something called structured similarity index. So you have to remember this. I'll ask you. So that's an Emmy Award winner technology. Kein Scheiß. And so 2015, it was awarded. It's also used in cinema and so on. So what does it do actually? It uses brightness, contrast, and structure to find out, to compare two images and find out where the differences are. And why is that important? Why can we use that for our problem? Because actually, so that's an example. If we compare this image, the original image, with this image and run it through structure similarity, it will tell us that's the difference and give it a number. So that means it's mathematical, yes, but it was proven that it's a really, really good human benchmark. So it really reflects also the human perception. So we can use that to find where is the point where the human eye actually starts seeing artifacts or differences between A and B, which we want to know, because if you have two, one is pretty lots of artifacts, one without, we want to see what quality level actually hits that point. So think about, not sure if you can see differences on this screen, but if you have different JPEG qualities, the DSSIM, so the structure similarity index, basically is different. And this number can be used as an abstract level of quality that you can choose for your, no matter what encoder you're using. Because it has different numbers, you can't really come up with one number. And you can use that because it also tells you good human benchmarking. So behind that, if you look at the heat map that generates, actually you see there are more differences here than there. Pretty simple explained, but that's how it works. Pixel by pixel comparison. We need to do that for every image size, for everything, because everyone has a different SSIM. Sounds complicated. So what does it actually does? I took an image. By incident, it's JPEG 99, so high quality. That was the hero image from the last page, I think, from code.talks. Size is 300 something. If you run that to structured similarity, and we tell an abstract level of perceptual medium. So actually, if you have low, it's pretty much the thing where you see artifacts, and then you can tell us high, medium, low. You know, how far do you want to go away from that abstract level where human eye starts to see something? We say medium, so there's still some delta between where we see something. Only that. And we do the format switch. That means we look at every single image. So if a Chrome comes, we know we can use WebP, we can use JPEG, we can use PNG. So we go through all of them, go from JPEG 100 and WebP 100 down until we hit the level that we arranged, so the number of structured similarity. And then just check what is the lowest number, what is the smallest byte size, and that's the image that's been delivered. That means at the end you will have the same quality image, so no visual change. In WebP, it's just 27K, 91% low. In Apple, it's 40, but still, compared to 300, and visually no difference, you can imagine how fast the site now is, right? So that's pretty cool. Now the delivery. Getting difficult. How do you actually implement that? So there are browser solutions. Talk a lot about that. The browser knows a lot, so why don't we use that? You can, of course, use JavaScript. You can use server-side rendering of that, giving all the information to the server. You can use third-party libraries. Let's start with source set sizes and client hints. So probably you think, let's do media queries in CSS. That's what comes in mind. You can do that, but it's really getting complicated. Because think of a perspective of the developer while he implements that. What information does he have? Does he have the information of the viewport, of the size of the actual device? Not at coding time, not really. The browser knows, so he has to pull it somewhere and put it in CSS. It's possible, but it's complicated. He knows the image size relative to viewport. That he knows. The browser does not know that. Must have some input from the customer or from the developer. Screen density, same thing. It's browser knows it. Developer not really. And he knows the developer knows the source file destination dimensions. We don't know, although the browser does know. So can we change that with using source set? So first of all, if you let the browser choose, actually with source set, you can tell him, use source for fallback. In terms of a really old browser that does not support source set, but all new modern browsers actually do that. And then you can tell, that's the available versions I have from that version for this image. One is 300, one is 500. And then tell it basically, based on the browser view size, select the right image. With 300, select 300, 400, select 400. And that's it. Basically pretty easy. You could also use, instead of pixels, you can use viewport percentage, basically. Say, use the 300 image if it's 100%. If it's 50% viewport, use the smaller image. So that basically turns those two into green. We pretty easily can use source set to tell when to use what image at what size relative to viewport, and also basically based on the original dimensions, choose the right image. I'm not going to client hints, but client hints basically give this information to the backend. You can do server-side rendering for that. Think about it, but sometimes it's also complicated to do that way. So in general, source set is okay for simple switching of the formats, but what about image formats, art direction, all of that complexity that we just saw? Let's look at the picture element combined with source set. Picture element is also supported pretty widely by all browsers now. If not, there are fallbacks in the picture. So if you look at the picture element in detail, what you can do is, the picture element is new picture, right? Then you have multiple sources. You can tell, similar to the source set, use that 400 width, and then as soon as you're above 400, use that, and above 800, use that. And then you have an image tag as a fallback. So basically, if the browser does not support that, at least you have an image, probably the smallest one. So next thing, format. You can add the format as type. You can tell the browser, and it's basically the browser goes through all variants, looks at which situation is it, and will pick the one that fits them. So it will, if it supports WebP, it will choose the WebP. Otherwise, it will go down the stack. So that's a way to do that. But you see, it's getting complicated. Now imagine the art direction. You'll have a lot of code. You can also do resolution switching with picture element by basically adding this density descriptors, 1x, 2x, 3x. And it will basically just, as soon as it's 2x, it will use the 600. So as you see, it shows something like image service that actually gives us in real time the width that we need. Just heard it from About You Cloud, that basically that's what you want to do. You want probably not to create all those renditions, store them somewhere, and so on. You just want to ask URL-based, give me that width. No matter if it's a parameter or part of the URL, so depending on your syntax. Anyway, that's an easy way to do, then in the front end, basically, you can build that without going to the CMS again, asking about a new version, and that could be pretty painful. So, and then you can add that with resolution, so you'll end up with something like that. So you have multipliers. You can also use, and now it's getting complicated, you combine those sizes with general percentage. So you can tell them, you know, when the screen is under 1024 and the image takes up more than 50% of the viewport, here are 3 sizes available for you. So mix and match that, which is pretty powerful and actually should give you all the possibilities you need to do that. Art direction, same thing. You can say as a certain, for example, the cropped image, the dolphin that we saw, I want to display it if the minimum width is 1024.5, so at a certain point, choose that. The browser never loads all of that. That's important. You don't want to have 15,000 images loaded because you just display one. It will choose the situation and will do the HTTP request that is actually done here at that point. If you scroll down, if you basically lower the viewport, it will fire another request. So it's pretty, that's built in HTML5, pretty easy to use. Yeah, and you can basically use for desktop also the uncropped version at the end. So this is pretty complex, and then the question is, what can we automate? What should we automate? What can we do ourselves? So first thing, if you use an image service, you know, rendition generation is maybe the easiest thing to automate. No one wants to go to Photoshop and does that alone. Don't run their own script or whatever. You want to have instant real-time manipulation of images in terms of sizes. So you can really code that in and you'll get the image that you want. So that's the first thing. How does the browser does that? Does you need JavaScript that does something? No, basically just tell the browser with the size and so on. Use basically policies maybe to have this information, group pictures like product detail pages as a policy, then you have different policies, and then you have different sizes within the policy, and then you can really say, I want from this policy this image, and crop it from there and there. So lots of possibilities in terms of transformations. So cropping, cropping by face, you know, there are lots of things. For e-commerce, product image, cropping, removing the white space around and shrink wrap the product page, things like that, which is normally lots of effort. Do that automatically. Use the algorithm that's out there. And just use the picture and source set and hints and so on to drive your experience. Hints, I mean, you have to give us the information what width you need. You have to have basically, so just the HTTP request will never know in what dimension, art direction you want to have that. So we have to have some hint. It could be part of the URL, like if everything in this thumbnail folder in the URL should be size X. That's one possibility. Or you add a parameter like width, or you add cropping parameter, and so on. So that's something that's pretty easy, and maybe some of you already use it as an image service. It could be in-house, it could be an image service in the cloud, doesn't really matter. So then the more complicated stuff is here. Choose the correct image format and compression for every single image. So ideally, do the first transformation visually in real time. Then take this image out of the cache, find the right format and right compression, and switch the cache. So basically, the developer has not to think about compression and format. We'll remove this type from the image from the picture tag. Doesn't matter, because the image service will do that, and will switch the image in the cache without even visually noticing. No one will notice that. Actually, if you think about a URL with .jpeg, the .jpeg is just the name. Doesn't matter. You can remove that. Just say image hashtag. That's the image name or PIM number or whatever. Important is what MIME type comes back, and that browser interprets that. So that can be dynamically done. Request comes to image service. Image service does this picture by picture, knows it must end up with WebP 65, delivers that. So you end up every single image, every size of every single image will be a different format, a different compression based on the situation you are in. That's pretty cool, because that's the complex part. And trying to solve that yourself is really complicated. And the switching of the cache is also complicated, because you have to you have to invalidate and change that and so on. If the CDN itself does that, that's pretty easy. There's one more thing we haven't talked about, network awareness. So that's also something pretty cool, actually. If you know that someone is, let's say, on a mobile phone in the S-Bahn, full LTE, but the connection is really crappy, maybe your backend knows about the connection at some point, but it's not the real connection. So how can we get this information about the connection? We should first have a good measurement about connections on the device itself, send this information to the image service, and have rules about, in this case, not just hard-coded static compression rates. That's one possibility, but no. Why not choose different SSIM, basically, medium, medium, high, low, which is still above the fold that you don't see artifacts, but you have the variance in compression, and you lower the byte range immediately. You might have the risk in low to have a little artifacts there, but it's not as hard as, say, oh, like JPEG 20. It will always look crappy. So you still have this balance if you combine both. So that's also something you could automate. Let the image service compression, choose the compression based on network conditions, and use SSIM value instead of hard. So in the future anyway, rather use that than talking about compression quality levels for certain encoders, because it's not reliable and it changes, and there's no one fits all, and every format is different. So talking about this as an abstract level of quality fits it all, and it's pretty cool. So what can you do? Try out run your page to web page test, Google PageSpeed. They'll tell you a lot about image compression. They'll tell you about what you could do better, that you do more. So it will have direct influence on SEO, have direct influence on your page performance. So everything you do there is factor a lot. You know, the site is speeding up immediately, and the SEO ranking will speed. So think about images, maybe in a state-of-the-art way, a modern way. It's complex, but it's solvable. And if you solve it on an abstract level, you have a lot of benefits. So in general, if you think about image strategy, simplify where we can, but don't compromise ever on quality and performance, because quality and performance is what drives engagement, what drives your site. So that's what you should do, and automate as much as you could. That helps. That's actually the end of my talk. I invite you all. We have a little workshop with about actually APIs and DevOps, how to integrate CDNs effectively into your CI/CD pipeline. It's pretty Akamai specific, but maybe your company already uses Akamai. It's here in Berlin in 2 weeks, so you're invited. Otherwise, I'm open to any questions in English or in German. Check for source set and picture. You can use caniuse.com. Enter that, and you see the versions that support that. Source set more widely than picture, but both actually, if you look at all modern browsers, they support it. There are things like polyfill and other JavaScript that help you maybe do support picture across all, and if not, they will turn it into source set and things like that. But in general, there's a really good support, and most of the pages nowadays use that already. Yeah. Wait. Yeah. Mm. Do you also do the format switch in SSIM? Yeah, you can do it with Lambda. You can do it on your own. It's always depends on is that something you want to spend your resources on? Is that basically are you sure you don't create a single point of failure at some points? It's pretty important. You have it all in Amazon. It's still one point. If you have it on a let's say part of the CDN, like what we do, you have it. It's hardly coupled with the CDN with the caching, and it's basically near to every image server is close to the user wherever the user is globally. So that's basically the discussion. Do it yourself, or use a service. It's like for everything. It's something you have to check on prices versus value, I would say. Lots of large e-commerce customers say we don't want to spend our developer power on that. that's already solved. That's stable. That's nothing that drives, every hour we spend there, we could spend somewhere else. So that's something, and I work with all the big e-commerce customers. I don't know any of those that still use, I know a couple of them that still use their do-it-yourself, but I know that everyone is thinking about switching at some point, especially when you start with SSIM, because it's complex and it's a lot of power. Think about every image should be basically run through this algorithm. That's a little bit like the face detection, but you have to build maybe another worker that does that, and but yeah, it's possible to do it. Yeah, it's it is that. Yeah. SSIM is, there's a paper you can work, there's a Git repository you can fork. It's nothing that we invented. But as soon as you start with that, you will see that it's complex to implement at some point into a system. But it's nothing we invented. Every other image service that does DSS, there's no free tool. There's the algorithm that is out there, and there is a repository for a certain implementation out there. I haven't tried it out. I don't know about the quality. Basically, we forked that. We have then developed our own version of it, which is integrated into, think about storage, think about scaling, CDN, think about caching, invalidation, policies driven. So in our policies, that also tells you what renditions you will. You have to switch between the quality. Say I want quality medium high, and so the whole management of this stuff is more complex than the actual implementation of just this algorithm. Yep. Yeah, I mean, you saw that for the example. It depends on the image and depends on the compression. If you go from the we always go from the uncompressed big image, so 4K uncompressed TIFF, or something PNG, and then we can shrink it, and we can always get the best quality. If it's already JPEG 70 and you say please, or JPEG 50, it's hard to do to increase the quality. It's always you can't increase quality much more. You can decrease quality. That's easy. So if you have a large image, or if you have big JPEGs, if you have PNGs that are lossy, the effect will be high, until 60–70% less normally. If you have a ready JPEG compressed image, the effect of byte size might not be nice, but for the same byte size, you might get a nicer image because you're already pretty aggressive in compression. If you say the same byte size, you'll get an image that looks like a 4K, uncompressed image, although it's the same size. So no clear answer. It depends, but running it globally on an e-commerce, which we did without any code change, you can basically just say, I just want the optimization running for every single image and then deliver it. Showed normally around 30–40% less bytes. No more questions? Okay, thank you.